Greetings, Scott here, known as Cantaloupe to some online, and I'm bringing a video to you today about a subject that's interesting to me. It might be of interest to you or someone you know about, and it's going to be about gravity and my intuitive explanation of gravity. And for the rigorous scientists among us, that probably won't count for much because intuition is not commonly regarded as highly valuable in the scientific community, although it probably should be, if you ask me. Intuition is what helps us get from point A to point B when we're making hypotheses, which is, as you may know, if you're a scientist, a very important and integral part of science. So anyway, not to go on and on, but gravity is the subject, and there seems to be a great deal of mystery about gravity and some ideas, some possible explanations, but nothing that I've seen in official news or papers that explains it satisfactorily. So I'm going to do my best to describe how I've connected the dots, and my qualifications are almost insignificant. I don't have a formal background in academic physics or astrophysics or even quantum mechanics or anything, but what I do have is intuition, which I've mentioned already 3 times now. So for what it's worth, hear me out. So gravity is, from what I understand, a dual process, like we see in light, for example, with photons or electromagnetic radiation, where you have a dual state, where it's a particle and a wave. You've probably heard of this. Depending on how it's being observed, and it's almost literally how it's being observed, it determines whether it's a particle or a wave, in spite of reason and measurability. It's kind of a funny thing. Gravity is kind of the same way. It's a wave, and it's a an instantaneous field at the same time, but that's not really the substance of my observation. I'm going to describe something that is known and measured and proven in the laboratory currently. We have particle accelerators, we have particle colliders, the big CERN facility in Europe where we do these experiments every day. It's a big public facility where we observe and collide particles and look at the mess that comes out of them and measure things. And I don't know a huge amount about it, just that they experiment and they collect data and they report on findings, which is great, as long as it's being put to helpful uses and productive, healthy uses. So I talked about gravity. So what we know about particles, there's a connection. Particles, subatomic particles, when you get down to it, at a very, very, very small scale, subatomic scale, you have quarks and a whole big confusing mess of stuff that comes out of them. And what I think we've probably discovered, I believe we've discovered at this point, is there are at the smallest observable scale to us, we have things phasing in and out of reality, in and out of physical existence, however you want to say it. They're popping in and out of our universe on a very small scale. However, small or not, everything's made up of atoms in our physical world. Atoms, or I shouldn't say everything. Obviously, we have neutrinos, we have photons, we've got waves and fields and forces that aren't necessarily made up of atoms, but they are tied to those atoms. They're tied to the stasis of energy in the form of physical matter, and that physical matter is comprised of these things I just described, quantum states that are fluctuating. They're in a constant state of being born and destroyed very quickly throughout the entire universe. Everything, all the matter. So here's what happens in my understanding. So when something pops in, so to speak, when something becomes physical, it enters our dimension, our universe, from another dimension. And that's a really accurate, I think, way to describe it, what is happening. It's popping into our space and then back out. at sort of a flow, right? So that's popping in, other stuff's popping out, and you end up with the almost undetectable effects from this activity. When something pops in, you have, you're going to have to forgive me, it's either when it pops in, it repels, or when it pops out, it repels, and vice versa for attracts. It creates a field of attraction or a field of repulsion, and based on the rate of popping in and popping out, so to speak, it creates an average, a cumulative force. And this is, long story short, where gravity comes from. When these particles pop in or out on a massive scale, as in when you have a great deal of them together, such as with a planet or a star, you begin to observe in great force and magnitude these combined effects because they're all together, right? So, and they start to collect other ones because of the force that is exerted on them when their constituents are popping in and out. So, I can't give you any mathematical proof. I don't have the language, the terminology, or the background to express this in a formal, rigorous way that is provable and acceptable by the academic community. I have no peer review. I have no hypothesis formally, but hopefully that makes sense. So on a subatomic level, in summary, you've got states that are fluctuating, creating a cumulative field that is either attractive or repulsive. And when there's enough of it combined together, it's observable and felt by nearby similar matter, that is. There's more to be said, but that's a lot of information, and it's my intuitive understanding. So if you have questions or comments, reach out, whitehotrobot@gmail.com, and I hope you have a great day. Thank you.